Hey everyone, welcome back to BugNoJutsu. In today's video, we're looking at a very interesting problem from LeetCode, longest subarray of 1's after deleting one element. This is a medium-level problem that's great for practicing sliding window techniques and edge case handling. By the end of this breakdown, you'll fully understand how to solve it efficiently and cleanly. We are given a binary array, meaning it contains only zeros and ones. The task is to delete exactly one element from it, and then return the length of the longest subarray that contains only ones. Now, deleting one element is always required. If the array contains zeros, the best choice is usually to remove one of them to maximize the streak of ones. If the array is all ones, then we still delete one element, but the maximum subarray of ones will simply be the length minus 1. So the challenge is not only about finding consecutive ones, but doing so while respecting this deletion requirement. Take the input nums equals 1 1 0 1. If we delete the 0 at index 2, the array becomes 1 1 1. That gives us a maximum length of 3 consecutive ones, which is the answer. Another example, nums equals 0 1 1 1 0 1 1 0 1. Here, the best move is to delete the 0 at position 4. This allows the sequence 1 1 1 on the left to merge with 1 1 on the right, forming 1 1 1 1 1. The answer is 5. And finally, for an array like 1 1 1 1, even though there are no zeros, we must delete one element. After deleting any one, the longest run of ones will be 3. To solve this problem, I used the sliding window technique with 2 pointers and a simple counter. We maintain a window with indices I and j. As j moves forward, we expand the window. Whenever we encounter a 0, we increase a counter c. This counter keeps track of how many zeros are currently inside the window. The rule is that the window can contain at most 1 0, because we are allowed to delete only one element. If c ever becomes greater than 1, it means our window has too many zeros. In that case, we shrink the window from the left by moving I forward, and if we pass over a 0, we decrease c. At each step, the valid window length after deletion is computed as j I. Notice that it's not j I plus 1. By using j I, we automatically handle the condition of deleting exactly one element. If the window has a 0, it simulates removing it. If the window has only ones, it still subtracts 1, because deletion is required. This way, we continuously update our result with the maximum possible length of consecutive ones achievable after one deletion. Time complexity, O, n, where n is the length of the array. Each element is visited at most twice, once when expanding the window with j and possibly once when shrinking it with I. Space complexity, O, 1. We only use a single integer c to count zeros, along with a few variables for tracking indices and results. The main insight is that the sliding window technique is very powerful when we have constraints like at most k bad elements. In this problem, the bad elements are zeros, and we are allowed at most 1. By carefully maintaining this condition, we can solve the problem in linear time. Another subtle but important point is why we calculate the length as j I instead of j I plus 1. That small detail ensures the deletion rule is always respected. Even in an all-ones array, it correctly reduces the maximum by 1, because one deletion is mandatory. This version of the solution is also cleaner and easier to follow since it avoids extra data structures and relies only on a simple counter. And that's the solution to LeetCode 1493, longest subarray of 1's after deleting one element. We applied the sliding window method with a counter to track zeros and made sure the deletion condition was naturally handled in our length calculation. This approach is efficient, simple, and interview-friendly. If you enjoyed this breakdown, make sure to like the video, subscribe to BugNoJutsu, and share it with your friends who are practicing for coding interviews. Your support helps the channel grow and motivates me to create more clear explanations for tricky problems. Thanks a lot for watching, and I'll see you in the next one.